All right, hello. This is physics review problems for the final exam. This is problem number 3, which reads, a football is kicked off at a 40-degree angle with the ground at 16.8 meters per second. Part A asks us for the initial vertical velocity of the ball. And so what's probably going to be the most helpful here, I didn't write my equations. Oh no. Okay, let's work on the equations first. So we have, what we're going to need is EK is equal to 1/2 mv squared. EG is equal to mgh. Let's see. V is equal to AT plus the initial velocity, and the change in x will be 1/2 times the time times the final velocity plus the initial velocity. All right, now we're going to draw the picture. So we have here that the football is being kicked off at a 40-degree angle with the ground. So if we have, this is our ground, and this is our 40-degree angle. This is the direction of the football. This will be the x direction, the y direction, and we know that the velocity is 16.8 meters per second. So we can draw that in our picture right here. So now what we have to do first is solve for the initial vertical velocity of the football. And we can do that by using trigonometry. Since we have an angle, we have the hypotenuse, we can use sine, which is opposite over hypotenuse, or as in SOHCAHTOA. So we have the sine of 40 degrees, which will be y, or the velocity in the vertical direction, over 16.8 meters per second, which is the hypotenuse. And then now solving for that, or solving for y, we have that y, the velocity in the vertical direction, is equal to 10.8 meters per second. Now we should say that this is up. We have the velocity moving upwards, so we should make a note on our picture here that since that is the direction of the football, the velocity vector vertically will be pointing upwards. And since velocity has a direction, we do need to indicate that it is upwards. You could probably also know that it's upwards based on the fact that it's a positive value as opposed to a negative value. If it was a negative value, it would be moving downwards with a negative velocity. Now we're doing the same for part B. Oh, this is your answer to part A. So, part A. Now our answer to part B is the initial horizontal velocity, so the velocity in the x direction as opposed to the y direction. And we can solve that using cosine, which is adjacent over hypotenuse. So we have the cosine of 40 degrees equals x, which is the velocity in the horizontal direction, divided by 16.8 meters per second. Once again, using our calculator, we have that the velocity in the x direction is equal to 12.9 meters per second. And that's going to be to the right. Now technically, we should be able to know that based on the fact that it's a positive value once again. Of course, you should indicate the fact that it's right unless you have something in the problem that specifically designates the fact that right means positive. However, a negative velocity would generally indicate something moving in the leftwards direction. And so here we have our answer to part B, 12.9 meters per second to the right. Part C asks for the maximum height of the ball. And in order to find the height of the ball, what we have to do is set our energies equal to each other, or our kinetic energy, EK, equal to our gravitational potential energy, or EG, since this is where we can solve for our height. And so, what we're going to do, since we know that energy has to be conserved, we know that the initial kinetic energy of the ball, which we can solve for here, will be equal to the potential energy of the ball when it is moving, or when it's at its peak. So we can set EK equal to EG. Now we can see here that the masses of the ball will cancel out, which is good since they weren't given to us in the problem. And whenever they don't give you the mass of the ball where it seems like, or a mass of an object where it seems like you might need it, generally you'll be able to use one of these equations, particularly the energy equations, in order to get those masses to cancel out. So now we can rewrite our equation as 1/2 times the velocity squared equals G, or, well, we should make a note over here, G is equal to 9.8 newtons per kilogram. Although we can ignore those units now since we have lost our mass, and mass would be in kilograms. So we can ignore the kilogram units. So we have G times H, and H, of course, is what we're solving for. So we have to be careful here. Since we're looking for the maximum height of the ball, we're actually only using the y direction. We're using the vertical direction. And so we'll be using our velocity in the y direction that we solved for up here, 10.8 meters per second, up, as opposed to using the total velocity, 16.8 meters per second, or the x direction, which is 12.9. And so we'll have half times 10.8 meters per second squared is equal to 9.8 newtons per kilogram, although we're ignoring the kilogram units now, times h. Plugging that into our calculator, we get that the maximum height of the football will be 5.95 meters. And that is our answer to part C. That is the maximum height of the ball because that is where our potential energy is equal to our y kinetic energy, so our vertical kinetic energy. Next, we are solving for how long the ball will be in the air, and so we're looking for a time that the ball is in the air. And the way that we're going to solve for the time that the ball is in the air is by using the fact that in a projectile or an object in free fall, the acceleration is equal to negative 9.8 meters per second squared. And that's true of any object where the only force acting upon it is gravity, and this is one of those cases. And so we can use our equation up here, that v is equal to acceleration times time plus the initial velocity, to solve for the amount of time that the ball is in the air. And once again, we're going to be using our y velocities, so 10.8 meters per second up, as opposed to our x velocities or our total velocity. Since we're looking for the amount of time that the ball is in the air, we're going to have a total displacement vertically of 0. So we have our initial velocity in the y direction, which is 10.8 meters per second. That's up, equal to our acceleration, which is negative 9.8 meters per second squared. I forgot the squared here. 9.8 meters per second squared times the time, what we're solving for, plus our initial velocity in the y direction. So we have 10.8 meters per second up. Now, before we go any further, we do have to note the fact that our final velocity, our final velocity here, v, is not actually going to be in the upwards direction, since the ball is going to make an arc, where the ball is going to come up here, and then arc and come back down here. So while the magnitudes of the velocity are going to be the same, the directions of the y value, or the directions of the y velocities will not be the same. And so our final velocity will actually be negative as the ball will be falling back down towards Earth. So we have an up here, this is our 10.8, and we have it down here as, once again, our 10.8. And that goes by the property of projectiles, that when a projectile moves up and then comes back down, that at the same height, so if this is h, and in this case h is 0, that the velocities will be the same but opposite. It's the same magnitudes but opposite directions. So now solving for t, we can use this equation, and we should be able to calculate the amount of time the ball is in the air. And we get that out to be 2.20 seconds. And that will be our answer to part D. You can see the equation, or the calculations here. All right. Part E, how far away from the kick will the ball land? And so for this, we're going to be using our last equation here, that delta x, or the change in x, is equal to 1/2 times the time, which we just solved for, times the initial velocity, or the final velocity, plus the initial velocity. In this case, because we're going to be searching for how far away from the kick will the ball land, we'll be using the x velocity as opposed to the y velocity or the total velocity, since it's moving in a horizontal direction. So here we have that delta x, what we're solving for, the change, is equal to 1/2 times 2.20 seconds, which is what we just solved for here is the time, times, oh wait, I believe I wrote that wrong. I didn't write that wrong, never mind. Okay, we're all good. Times the velocity in the x direction, so 12.9 meters per second, plus 12.9 meters per second. And that's because in a projectile motion, the x velocity does not change. So the value of the x velocity doesn't change, neither does the direction. So the magnitude and the direction of an x velocity vector stays the same, which is different from a y velocity vector. And so here we can solve for delta x being equal to 0.5 times 2.2 times 12.9 plus 12.9. And that gives us about 28.38 meters. Now this number might be slightly different depending on rounding. I believe in the answer sheet it has 28.2 something largish, but really as long as you're, within the ballpark, you are correct in this answer. So like when I was solving this problem earlier, I actually got 28.31 because I left my numbers more exact and I did not round them as much here, but this is all correct per se. So now what we have to do is we have to search for the horizontal and the vertical velocities of the ball when it hits the ground. So I'm going to flip the page really quick to do that. Now I talked a little bit about this earlier, about how the velocities of the ball will be the same but opposite directions when in the vertical direction, and will not change in the horizontal direction. And so when we solved for the velocities originally, we found that the velocity in the x direction was 12.9 meters per second, and that the velocity in the y direction was 10.8 meters per second, I believe. I can double check that really quick. Oops. Right here, we have 10.8 in the y direction and 12.9 in the x direction. And so our final velocities will be, again, 12.9 meters per second in the x direction, in the horizontal direction, and that'll also be right. We can make a note of that if you'd like. But in the y direction, because we're going to be making that arc, like we mentioned on the other side of the page, where we begin up and we end downward, we're going to have a negative 10.8 meters per second velocity. And we can also call that down if you'd like. So, and these are our answers to part F, which finishes problem 3 on the review.